Okay, so let's have a look at the Gauss-Jordan elimination method to determine the inverse of a 3 by 3 matrix. So I'm going to start with this 3 by 3 matrix here, and what we're going to do is find the inverse of this 3 by 3 matrix. So what we're going to do is first of all just get rid of this here, and we'll just draw a line down along here like this, and on this side here I'm just going to put the identity matrix, so 1 0 0 0 1 0 0 0 1. So what I've done effectively is produced an augmented matrix. So what we're going to do is convert this matrix here, this side of the augmented matrix, to an identity matrix, and we're going to do that in a series of steps, and whatever we do to this matrix here, we're going to do the same to this identity matrix on the right hand side here. And what we should end up with on the right hand side then is the inverse of this matrix here, which let's say we'll call A for the moment. Okay, so let's start. What we're going to do first is, I'll put these little arrows down here just to explain what we're going to do in each step. So if I start here, what we're going to do is take row number 2 and row number 3, and we're just going to swap them around. So let's work through that. So we're going to take, we're going to leave 2 0 3 there, and we're going to leave 1 0 0 there, and we're just going to swap around row 2 and 3. So here we're going to end up with -3 1 -4 0 0 1. Down here we'll have -1 3 -4 0 1 0. Okay, so that's the first step. Let's move it on to the next step then. So what I'm going to do here in the next step is take row 1 and I'm going to add row 3 to it. So let's do that. So I'm going to leave row 2 where it is. So row 2 is still going to be -3 1 -4 0 0 1. So I'm going to take row 1 and I'm going to add row 3 to it. So if I add row 3 to row 1, what I'll get up here is 1 3 -1, and over here 1 1 0. And I'm not doing anything to row 3, so I'll just write that down again. So it's -1 3 -4 0 1 0. Okay, so next step. Okay, so what I'm going to do here is I'm going to take row 2 and I'm going to subtract 3 times row 3. So if I do that, row 1 will remain the same, so I'll still end up here with 1 3 -1 and 1 1 0. Row 2 will become 0 -8 8 0 -3 1, and row 3 will remain the same, so that will be -1 3 -4 0 1 0. Okay, so let's go again. Now remember, you don't have to necessarily use these particular steps. You might have your own version of this solution, but this is just the way I'm doing it. So let's see here. What we're going to do now is take row 3. I'm just going to add row 1. So that will give me 1 3 -1, again up here, 1 3 -1, 1, 1, 0. Nothing changes with row 1. Row 2 doesn't change either, so I've still got 0, minus 8, 8, 0, minus 3, 1. Now I'm adding row 1 to row 3, so that will give me my 0 down here, which is what I want. I'll end up with a 6 here, and a minus 5 here, and then 1, 2, 0 here. Okay, next step. So the next thing I'm going to do is I'm going to take row 2 and I'm going to divide by minus 8. That's going to give me a 1 in the middle here, and I will end up with a 1 here as well, but at least I'll end up with a 1 in the middle, which is what I want. I want a diagonal of 1s. So the first row still is 1, 3, minus 1. That doesn't change. 1, 1, 0. Second row now I'm dividing by minus 8. So this will be 0, this will be 1, and this will be minus 1 here. Do the same here. You get 0. I'm going to end up with 3 over 8 here and minus 1 over 8 here. Row 3 remains the same. So it's 0, 6, minus 5, 1, 2, 0. Okay, so next step then, I'm going to take row 1 and I'm going to subtract row 2. So I'm going to subtract row 2 from row 1. Okay, so first row then just becomes 1, 1 minus 0, 0, 3 minus 1, 2, and minus 1 minus minus 1 is 0. I want a 0 out here. So over here this becomes 1. 1 minus 3 eighths, 5 eighths, and 0 minus minus 1 eighth is 1 eighth. So everything else remains the same. 0, 1, minus 1, 0, 3 eighths, minus 1 eighth, and 0, 6, minus 5, 1, 2, 0. Okay, so next step. This time I'm going to take row 3 and I'm going to subtract 6 times row 2. So I'm going to multiply row 2 by 6 and subtract it from row 3. Okay, so row 1 remains the same, so it's still 1, 2, 0, 1, 5 eighths, 1 eighth. The second row, that's also going to remain the same, so I've got 0, 1, minus 1, 0, 3 eighths, and minus 1 eighth. Now I've got to get 6 times row 2, and I've got to subtract it from row 3. So that will give me 0, 0, 1. So you can now see that I have a diagonal here of 1s, which is what I want. Now over here I've got 1. This will become minus a quarter, and this will become 6 eighths. Okay, so we're almost there. Let's see. Another 2 steps I think should do it. So we have row 2 now, and we're going to add row 3. So let's do that. So row 1 remains the same again. So we've got 1, 2, 0, 1, 5 eighths, 1 8. We want to take row 2 and add row 3 to it. So row 2 now will become 0, 1, 0. And over here we'll get 1, 1 eighth, and 5 eighths. And then the bottom line should remain the same, 0, 0, 1, 1 minus a quarter, and 6 eighths. Okay, we're just running out of room here, so I'm going to come over this way. And this time what I'm going to do is take row 1, and I'm going to subtract twice row 2. And that should finish it off for me, I think. So here I'll end up with 1, 0, 0, which is what I want. Because remember, I'm taking row 1 and I'm subtracting twice row 2. So what I'm doing here is taking twice 2 and subtracting it from 2 here. So that'll give me my 0. Okay, so here I'll end up with minus 1, 3/8, and minus 9/8. Here 0, 1, 0, and 1, 1/8, and 5/8. And finally along here 0, 0, 1, 1 minus 1/4, and 6/8. Okay, so I've taken the left hand side, my original matrix A here, and I've converted it into the identity matrix. Now this over here then will be a inverse. This will be the inverse of my original matrix. This is the identity matrix here. So basically if I take my original matrix A, multiply it by A inverse, I'll just end up with the identity matrix. And that's it. That's using the Gauss-Jordan elimination just to determine the inverse of a 3 by 3 matrix.